Professor, thank you for reviewing my previous demo video and sharing your valuable feedback. My name is Hasnain Haider, and in this video, I will address the two questions that you mentioned in the email. For your first question, I have prepared a PPT that explains how the microservices communicate with each other. For your second question, I will run the system and show two users editing the same document side by side, so you can clearly see how sharing and collaboration works between two users. So let's begin. So this is the PPT that I have made to address your first question. How do microservices communicate? Microservices are communicate in two ways: synchronous or either asynchronous. Why microservices communication is challenging? Microservices are distributed, flexible, and highly scalable. Microservices are very scalable, but communication between microservices is a key challenging and very complex. Choosing between asynchronous and synchronous communication is a key design decision in microservices. Synchronous versus asynchronous communication. In synchronous, callers send a request and waiting for a response. Useful when an immediate reaction is required. Like we use synchronous communication in login, user enter his name and password to and send request and waiting for the response. While asynchronous, callers send a message and continue without waiting. In asynchronous communication, caller didn't wait for the response. Useful when an immediate response is not required, like we updating our settings. Why are asynchronous patterns in microservices? Microservices communication can be categorized as synchronous or asynchronous. Asynchronous patterns allow services to communicate without blocking each other. In asynchronous, the services communicate without blocking each other. They help simplify and streamline microservice architecture. Developers choose patterns based on responsiveness and decoupling needs. Advantages of asynchronous patterns. They are in asynchronous patterns. It's are scalable, reliable, and testable. If we see in scalable way, process may take time, but every request will eventually be handled. Every process eventually will singly be handled. Like when user send request of login, it is handled eventually. Like if we see in reliability where asynchronous messages preserve request even when services are offline. If we see it in testable, you do not need the entire service mesh running to test a single service. Uh, they are testable like in this way. When there are many microservices in our system, we test each microservice by itself, not the whole system to be tested to test a single microservice. Disadvantages of asynchronous patterns. Asynchronous patterns add complexity to system design and implementation. While we designing and implemented the system, it asynchronous patterns are very tough to implement and complex. Instead of simple request response, service must send, receive, and correlate messages. Client may need reply queues and message IDs to match response to a request. To match a single which response belongs to which request, we have to test the services. Choosing the right communication style. Asynchronous methods are often preferred for scalable, resilient microservice system. Synchronous calls are still useful when immediate, strong consistency is required. A hybrid approach using both styles where appropriate is common in real-time systems. Understanding these patterns leads to reliable, responsible, and maintainable applications. Like choosing the right communication system in the microservices, like we use synchronous and asynchronous communication. We have to check where we have to use asynchronous communication and where we have to use synchronous communication. If we check this in our system, our system is a hybrid approach, hybrid model. We use hybrid model. We use asynchronous and synchronous both communication. We use asynchronous communication in our login system. While user login his system, we use asynchronous communication. In synchronous communication, when user share the document link and collaboratively editing the same document in multiple users. This is a live multiple users typing the document. It is synchronous call. Synchronous communication diagram. Service in this diagram, service A calls service B synchronously through a load balancer. A service A waits while one of the service B server handles the request and send back to the response. Here in the diagram, service A calls the service B and waiting for the response. It is asynchronous communication. The client is blocked until service B finishes the process. If service B didn't communicate with service A, service A waiting for his request in synchronous communication. If we see like asynchronous communication diagram, this is the diagram that I have made. A service A sends message to queue. In this diagram, asynchronous service A request to the queue, not directly request to the service B. Queue instead of calling the service B directly. Service B reads the message from the queue and process them on its own time. Service A does not wait for the response, which improves decoupling and scalability. This is the asynchronous, which we have used in our multi editing document. How our system microservices communicate. Our system uses a hybrid model. As synchronous communication manages structured operations like document sharing, while asynchronous WebSocket messages handle real-time updates. In our system, we use hybrid model. We use synchronous communication and asynchronous communication both. Our system hybrid communication flow. This is the flow that I have made to understand the our existing system communication. Our system uses RESTful APIs for structured operations like sharing documents, syncing with database, while WebSocket handle real-time editing and live updates between multiple users. If we elaborate this document, users, according to our system, user click click to generate the link. The RESTful APIs request to the web database using the WebSocket, and this user have and in the response, this user get a URL of sharing with other users to collaborate in his document, and then using WebSocket he will be communicate he will using he will be the multiple users communicate in the live editing, like this user click share the link and generate the database, the API's request to the database, and in the response the user will get a URL, and this URL, using this URL, he will be able to invite other users to collaborate his editing system. Like he sent other user, and other user click to join the link using WebSocket. The multiple users are communicate in live editing in our existing system. Our system communication pattern. Our system synchronously call for sequential actions like sharing, retrieving, and saving documents, while asynchronous event-driven updates handle real-time typing and collaboration without blocking. Like in our systems, asynchronous and synchronous communication. How asynchronous and asynchronous communication is performed in our existing system. Like when user click the share the document, in synchronous case, user share the document, get the document, save the version, which is version control, and the sequential user A types, server process, non-blocking and event-driven using the WebSocket. They both users see their live typing and live collaboration in the system that the first user share. Two users editing one document. Two users editing the same document see live updates instantly through asynchronous WebSocket events. User A and user B. So that's all for the PPT. So now I will briefly show you how two users communicate on a single document, how two users can collaborate on a single document. Any edits from one user, it instantly appear for the other. I already run the system, and I logged in. I will log in user 1 and user 2. I already create accounts for user A. I will log in user A here. Min I will log in user 1 here. There is no document here. Uh, I will create a new document for this user A, like new doc. Create. The user A is create the document. This is I will of this video photo save. This is the user A document. Save the document. This is the document that user A created. if if this user A wants to share his document with other user by using this share button, he will be able to share his document with other users, with multiple users. Like if he click in here, the I use APIs in front end to communicate with the microsystems. When user tap on this share icon, he will send request to you, using the RESTful APIs, and in the back response he will get a URL. He will get a URL in the response of the API. When he click on OK, the link of the sharing document is already copied for in user A. User A will share document with user B. I already create user B. I will log in user B here. This is the user B. There is no documents made by user B here. This is the user A and this is the user B. Now when user A tap on share, the link he get a link to share his document with other multiple users. When he tap on OK, the link is copied. This link is when the other user paste click on the link, he will be access to the this document. He will be access to this document. Did you see here user B collaboration is already shown in here that user B is in your document user A, like when this user B is appear here is only user B because this user A is sharing document with user B. Now when user I will refresh both tabs, to show instant editing. Like this user B is typing, this is user B. Did you see here? This is user A. This is user A. User A sees that remote changes detected by user B. User B is made changes in your document, like here. Uh, this this is user B edited by this document. The changes are instantly appear on the user B. Now when user B types this is did you see here in user B? Here is the user B. He will see. I will refresh this. I will refresh both tabs. Uh, this is user. Did you see here remote changes detected by user A? User A is made changes in the document, so it will appear in the user B screen. Did you see here remote changes detected by user A? When user A made changes, it will show in the user A, and when user B made changes, user A will be see the changes that user A made the changes, and if user B typing, user A see the changes, and if user A typing, user B will see the changes. Did you see here? This is me user A. Did you see it will instantly appear on the user B. This is user A. This is user B. This is user A. This is user A. Did you see the one side changes can instantly appear on the other side in real time? So both users can lively collaborate on a single document. By using this share link, the user will be able to share his document with other users, multiple users. And that's all for your second question.